In this video, we're going to find the derivative of y equals the quantity 6x minus 4 raised to the fifth power times e with the expression 3x squared minus 4x in the exponent. So there's a lot to unpack here. One, we have some multiplication. So first and a second piece. Remember, if we have the derivative, we're taking the derivative of some first times a second, my product rule would be first second prime plus second first prime. All right, and so as we spread that out, we're going to see the chain rule in there. So I'm going to start this problem, the derivative of y with respect to x. So my first is 6x minus 4 to the fifth power. Then we have times the derivative of the second. So that would be d dx of e to the 3x squared minus 4x plus e to the 3x squared minus 4x times the derivative with respect to x of 6x minus 4 to the fifth. So I've set this up using my product rule for differentiation. I now have two derivatives that I'm going to need to find. Once I'm done taking these two derivatives, I will be done with the calculus and we'll move ahead to the algebra. Both of these derivatives involve the chain rule. And remember, when we think about the chain rule, we say derivative of the outside times the derivative of whatever is inside the parentheses, in the argument, in the denominator, in the power. All right? So what this continues on looking like, I've got 6x minus 4 to the fifth. So the derivative of e to anything is e to that value. But now we need to multiply by the derivative of the exponent. And the derivative of the exponent here would be 6x minus 4. I used the power rule there. So now I have e to the 3x squared minus 4x. And I have one more derivative I need to take. So thinking about the outside, the 5 will come down. That will become a 4. So I have 5, 6x minus 4 to the fourth. And then I need to take the derivative of my inside. And that derivative there would just be 6. So pause the video if you need. Make sure you understand where all of these values are coming from. And right here, this 6x minus 4, I really need parentheses around that. So at this point, we're done taking derivatives. I'm going to kind of organize, and then we'll look at cleaning up and factoring out a GCF. So for the first term, I have 6x minus 4 to the fifth times another one of those. That's going to leave me with 6x minus 4 to the sixth. So I have 6x minus 4 to the sixth times the quantity e to the 3x squared minus 4x plus, now looking at our second piece, the 5 and the 6, that's going to give me 30 of these 6x minus 4 to the fourths. So I have 30 times 6x minus 4 to the fourth, and then again times my e to the 3x squared minus 4x. And I just switched those around so that they would be in the same order as the first term. So that's completely legal to do because multiplication is commutative. All right, so we're almost done here, but we have essentially two terms. Got my first piece and my second piece. And what I need to do is look at these two terms and say, what do they have in common? Is there a GCF that I can factor out? And so what we'll notice is that both of the terms have this e raised to a power. So I'm going to factor that out. That's e to the 3x squared minus 4x. When I factor that out, those are not going to belong in either term anymore. So also I'm going to look and I'll notice that I have 6x minus 4s and 6x minus 4s. And what we know when we're factoring out a GCF, we always factor out the least amount. So I'm going to pull 4 of those out, which for the first part, 6 minus 4, that's going to leave me with a 2. So I'm going to pull out 6x minus 4 to the 4th power. So what does that leave me with? My first term, I had 6x minus 4. That is now squared. And my second term is plus 30. This was left, and this was left, and that's what ends up here. So we're almost done. This is the same as e to the 3x squared minus 4x times 6x minus 4 to the 4th. And here, if I were to FOIL this, I would get 36x squared minus 48x plus 16 and then plus 30. And 16 and 30, when I add those together, that's going to give me plus 46. I'm essentially done, but when I look at this last piece, I notice that all of those are even. So realistically, it's very easy for me to factor out a 2 and possibly even a higher valued GCF. Now, when I look at this, I notice that they all have a factor of 2. And if I were to factor a 2 out of 46, that's 2 times 23, which is prime. So 2 is the largest number I would be able to factor out. So I'm going to pull that 2 in the front. E to the 3x squared minus 4x times the quantity 6x minus 4 to the 4th power. And factoring that 2 out gave me 18x squared minus 24 minus 24x plus 23. And I do not think this factors here anymore. But again, we're always looking to factor because factored form is the easiest for us to deal with when we are manipulating. So my derivative of y with respect to x of my original function here is listed as this. Please feel free to email me if you have any questions. Just do note that you will be required to factor GCFs out like this. This is a really important skill, and it really involves a lot of algebra. And that will conclude this video taking the derivative of exponential using both the chain and the product rule.